Hello friends, in this session we are going to cover all the remaining topic from packages and interfaces. In the previous session we were seeing how to implement a growable stack, that is dynamic stack. We will continue with that example. Following is another example for dynamic stack. Each stack is constructed with an initial length, and if that initial length is exceeded, stack increase in size, that is doubled. Now two variables, same variables, private integer stack array and top of stack, and dynamic stack integer size. Size is the initial size of the stack. And top of stack is equal to -1. Now pushing the item. If top of stack is equal to stack dot length -1, if stack is full, what I will do? I will double the stack size. In integer temperature array, temp array is equal to new int stack dot length into 2. If suppose initial stack length is 5, I will double it, I will make it 10. If initial size is 20, I will double it, I will make it 20. And for stack length, I will iterate temp of 0 or temp of I is equal to stack of I, stack it is equal to temp, and stack of top of stack is equal to item. So I will put the item into top of stack, push the item into top of stack. And otherwise, if stack is not full, I will just increment the top of stack and then I will put the item. For the previous stack length, I will put the previous stack elements into stack temporary array, and then I will replace it, swap it, and stack of top of stack is equal to item. Okay. Then pop stack and pop the item of the stack and decrement the top of stack by -1. Then I create two dynamic stacks, dynamic stack 1 and 2. Then pushing item and popping item is same as usual. The following class uses both fixed and dynamic stack implementations. It does so through an interface reference. This means that calls to push and pop are reserved at runtime rather than at compile time. Creating an interface reference variable means what? You are calling, you are resolving the call to push and pop through at the runtime. That is, which type of object you are passing to the reference variable. Depending upon that, it will call push and pop of the static or the dynamic stack. So we are creating two objects now. Dynamic stack ds is equal to new dynamic stack 5, and fixed stack fs is equal to new fixed stack 8. Now I will load dynamic stack into my stack variable. My stack is a interface reference variable of interface stack. So my stack is equal to ds. Now it is pointing to the object of dynamic stack, and then push some items onto the dynamic stack. Now it is loading fixed stack. My stack is equal to fs, so it is pushing onto the fixed stack. Now dynamic stack is my stack is again pointing to dynamic stack, and it is popping, and here also it is pointing to the fixed stack and popping. My stack is a reference to an integer stack in stack reference. When it refers to ds, it calls the push and pop from dynamic stack, and when it refers to fs, it calls the push and pop from fixed stack. And all this made at runtime. Accessing multiple implementations of interface through an interface reference variable is the most powerful way that Java achieves the runtime type for polymorphism. Now variables and interfaces. Variables in interfaces. You can use interfaces to import shared constants into multiple classes. Why shared constants? Whatever we are writing into interface as a member variable, that must be final and that must be static. What does that mean? And it must also be initialized. What does that mean? It is a constant. And whenever you are implementing that interface, you are indirectly calling the or accessing the constants declared in that interface. So you can use interfaces to import shared constants to multiple classes by simply declaring interface that contains variable that are initialized to the desired value, that is declaring the final variables into the interface. When you include that interface in a class, that is when you implement the interface, all of those variables names will be in scope as constant, means like in C and C++. In C and C++, what we were doing, we were declaring a constant in a capital defined constant, like that. Same using interface constant variables. If an interface contains no methods and any class that is implementing that interface, it means that does not actually implementing anything. It is as if that class were importing the constant fields into the class namespace as final variables. So automated decision makers, the next example we are going to see here. uh, these variables are created constants, shared constant. No is equal to 0, yes is equal to 1, maybe is equal to 2, later is equal to 3, soon is equal to 4, never is equal to 5. So now this question implements shared constant. Now random number is generated. Ask probability 100 into random dot next double, it will be converted into integer and it will be saved into prob variable. If prob is less than 30, return no 30%. Else if probe is less than 60, return yes. If probe is generated as less than 75, it will return later. It is less than 98, it will return soon. And lastly, it is 13 or 2% for never. Now, in answer we are passing the result. So we are switching to result. If it is no, it will print out no. If it is yes, it will print out yes. If it is maybe, it will print out maybe. So depending upon this constant, these values we are passing, no, yes, later, soon. So it is returning in integer format. Like if it is returning no, means it is returning 0. It is returning yes, means it is returning 1. If it is returning maybe, it means it is returning 2, like that. And whatever the result is came from that ask me, it will be passed here, and depending upon the result, it will display the output randomly. So question dot ask will return the result. It will pass to answer. Answer will be displayed. Like in four times we are doing the same thing. Notice that this program makes use of one of Java standard classes random, and it generates pseudo-random numbers. It contains several methods that allow you to obtain random numbers in the form required by your program. So there are multiple methods available in that class called as random, and it allows you to obtain random numbers in the form required by your program. There are several methods available. In this example, method next double is used. It returns random number in the range 0.0 to 1.0. That is its usage. So we are converting into integer. In this program, the two classes question and ask me both implement the shared constant interface where no, yes, maybe, soon, later, and never are defined. Inside each class code refers this constant as if each class had defined that directly. Constants are implemented as from interface, but they treat them as they are directly, or they are actually creating those variables. Here is the output: later, soon, no, and yes. So every time this result will not be the same. Later can be 2 times, soon can be 1 time, and there can be any sequence of this output. It depends upon the random number generated at runtime. Now interfaces can be also extended. One interface can inherit another interface by use of keyword extend. The syntax is same for inheriting classes. When a class implements interface that inherits another interface, it must provide all the implementation from the inheritance chain. Means all the interfaces that are declared in the chain. Now we will see the example. Interface A, void method 1, method 2. Two methods are there. Interface B, extend A, it adds method 3, and my class implements B. So my class must implement this method as well as these two methods. So method 1 is implementing, method 2 is implemented, method 3 is implemented. So object dot method 1, method 2, and method 3. You might want to try removing implementation for method 1 in my class. This will cause a compile time error because it is implementing that interface which is inheriting the another interface. So it must implement all of the methods. It will give you compile time error. Any class that implements an interface must implement all the methods defined by that interface, including any that are inherited from another interface. Interfaces and packages, both of these tools are important part of Java programming environment. Virtually all real programs that you write in Java will be contained within the packages. Without packages, you will not write anything. So every time you will need packages. Every time you have to understand what are packages, how they are created, how they are used, and number will probably implement interfaces as well. Virtually all real programs will implement interfaces. When you will actually implement these packages and interfaces, you will get their usage. It is important therefore that you should be comfortable with their usage. So all the videos we have seen till date, from the chapter number 1 to chapter number your 8, this chapter is packages and interfaces. For this I have taken reference notes from the complete reference Java book, and this is the attribution for the icons that I have used in my previous slides PPTs in the theory part. I am thankful for all the icons. They are royalty free images, but I should and I must give the attribution to these links. So please note down these links. These are very important, and I'm thankful to all these links, all these icons. These are all the icons I have used in my videos. So this way we have completed packages and interfaces theory last part, that is part 3. From the next session we will continue with the practical part. So meet you in the next session. Thank you so much.